For as long as humans have known that the stars in the sky are other suns, they have been asking themselves, are these suns orbited by other planets? Is there life out there? Are we alone in the universe? Since the discovery of the first exoplanet only 25 years ago, Hubble is among the many instruments trying to answer these questions, and astronomers are using it to hunt for life on other worlds. "25 years have passed since the first exoplanet was discovered, and 8 years since Hubble made its first direct image of an alien world. While in the beginning we knew of only a few very massive exoplanets, most often close to their parent star, today we know of more than 3,000. They are of different sizes and orbit various types of stars at different distances. But one thing hasn't been found so far: proof of life. Despite all the progress made in recent decades, the hunt for exoplanets is still a challenging one. They hide in the shadows, giving off no light of their own. Any starlight they reflect is swamped by the overwhelming brilliance of their parent star. This makes it especially difficult to find Earth-sized planets in the so-called habitable zone, the region around the star where liquid water can exist on the surface of a planet. And water is essential to all life as we know it. Water only remains liquid within a narrow range of temperatures. If a planet orbits too close to a star, the water evaporates. Too far away, and it will freeze. The thin band between these extremes, the habitable zone, represents the most probable abode of alien life. So, if we know where to look, how will we know if alien life exists on a faraway planet? No currently available or planned telescope is able to resolve the surface of a planet. But radio telescopes keep listening for messages from other civilizations, in the hope that they are as curious as we are. We could also be lucky and find signs of advanced civilizations, something like a ring world, a giant artificial structure built around a star. But the chances of such a discovery are rather low. In their search for life, optical and infrared telescopes focus on the analysis of exoplanet atmospheres. Life is capable of changing the composition of a planet's atmosphere on a grand scale. The oxygen in the Earth's atmosphere was released billions of years ago by microscopic organisms. If a similar process has occurred on other worlds, we may be able to detect it in the spectrum of the planet. From late 2016, European astronomers will use almost 500 orbits of Hubble, corresponding to just over a month of observing time, to make a detailed study of the atmosphere of hundreds of already known exoplanets. Hubble has studied alien atmospheres before, but this program offers an unrivaled chance to learn more about them than ever before. The data we gather in the next months from Hubble will be a fundamental database for further studies. And with the power of the upcoming next generation of telescopes in space and on the ground, astronomers may be closer than ever before to discovering life elsewhere in the universe.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESOcast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.